Welcome in Unit 1 to Section 1.5 on problem solving. We've talked a little bit before about how taking problems and putting them into words can be very helpful. We've done it with finding when we had our person with their base salary and their commissions and the total and kind of making a problem out of that. And we're going to do that here in a little more in depth. Verbal models, again, we've done that before. Make some labels, turn it into a math problem, which we've done, and then solve it. So we've done this already, but now it's just being a little more focused on it. So number one, a little deeper of a problem. We have a lawn care business. We want to know how much money we can spend on gasoline to travel to out-of-town clients. I'll get it out. In a typical week, you drive 600 miles and use 40 gallons of gas. Gas costs $1.25 per gallon, and your truck's fuel efficiency is 21 miles per gallon on the highway and 13 miles per gallon in town. Now that can be a little overwhelming. You have all these numbers and all these different things, and we're trying to figure this part out. So the first thing we want to notice is, okay, that's what we're looking for out of all of this. How much money do I have to spend on gas to travel to out-of-town clients? Okay, so what are we looking at? Again, let's put it into words. We're going to have our in-town travel plus our out-of-town travel equals the total. Now there's some things that go into each of those. We know that within any particular week we drive 600 miles and use 40 gallons of gas. Now you'll notice talks about the amount per gallon, talks about miles per gallon and miles per gallon. So let's figure out with our vehicle how much we actually get per gallon. So 600 miles over 40 gallons would be 15 miles per gallon, which we now call a gas guzzler. So it looks as though for our in-town travel, okay, we get 13 miles per gallon. Out of town, out on the highway, we get 21. And it looks like at the end we average about 15. Now that's just the miles per gallon part. What we have to figure out now is taking a peek and saying, okay, what numbers haven't we used at this point? Well, we used the 600 and the 40. We used the 13 here and the 13 here. Now $1.25, but let's think about this for a minute. To travel to these clients, we've got to figure out, we're going to use 40 gallons of gas. Okay, so basically we got to figure out how much gas we're going to use in each of these areas to make this work. Okay, so we're actually not going to use the amount of money per gallon until the end part. So sometimes we may have to wait with some values here. Since I'm looking for the gasoline to travel to out-of-town clients, we're going to make that X. So let's say, for instance, I spent 25 gallons to out-of-town traveling. How many gallons would that leave me for my in-town if there's 40 total? Okay, 15. What if I did 10 gallons of out-of-town travel? How much would that leave me for in-town? 30. Now we have to be abstract a little. Because if we look at this, and I know we're doing a whole bunch of different side little things here. So let's look at it this way. So in and out. Just thinking with numbers. So if out was 25, we figured out in's 15. If out was 10, we figured out in was 30. What's the pattern here? Okay. We're doing 40 minus our out equals the in. So if out equals x, in has to be 40 minus x. And you may be saying, but I haven't done anything with the $1.25 yet. I get this, but we have to know how many gallons we used in each place before we can worry about that. We can't have so many different variables going on that it makes this difficult for us. So here's our actual equation. We've got everything labeled in. We've got our algebraic model. So we're going to go ahead and distribute. We'll combine our like terms. And we'll find out that x equals 10. Now, 10 gallons for our out-of-town travel, but is that the question? How much money can you spend? Oh, times $1.25 a gallon means we're going to spend $12.50 that way. So there's a lot to this as we're trying to working through. Now, not every problem is going to be quite as detailed and complex as that first one that we did. Even though we've seen we can take care of it, it's nothing that's going to be too terribly awful. But for these last couple, these are going to be a little more basic in thought. So, below, the table gives the height to the tops of the first few stories of a tall building. Determine the height to the top of the 15th story. Now again, we're still going to come up with an equation for this. Even if you sit there and go, yeah, but I see it's just plus 12 every time. I'm just going to keep adding 12 till I get to 15. No, because what if I change this to determine the top of the 150th story? That's the thought process I want you to be able to work with here. So, even though we can absolutely see that the pattern here is that we are adding 12 and adding 12 and adding 12 to the height of each one, let's think about this. So our height is going to equal our base plus 12. And the base of our building being the lobby. We're going to be adding 12 each time. So let's look at it this way. My height is going to be 20, because that's the height of the lobby, plus 12, depending on what story we're going to, x. X equaling the story of the building that we're looking for. And the way that this ends up being nice now is that I know this is how it works. If I want to find the height of the 15th story, I just plug it in. Now again, you may decide you're going to say, well, I could have told you that, a couple minutes ago by just doing plus 12 plus 12. Right. But like if I told you, if I made it 150, would you be doing so quickly? Maybe not. So that's how we kind of work these problems, but it's more the process that we're getting you used to. So when you do have a problem that you can't just do mentally, this guy, okay, that you're going to be able to do it. And that's the whole idea. It's teaching you a way of thinking. And that's the way we've got to look at these. So finally, we have to find the seating capacity of two airliners. The Boeing seats 100 more passengers than McDonnell Douglas, and the two together seat 696 passengers. Set up a model and solve. Okay, now again, let's look at this. The two together. So Boeing plus McDonnell Douglas equals the total. Well, we know the total is 696 passengers. And we are trying to figure out how many passengers go with each. So let's see what else we know. The Boeing seats 100 more than McDonnell Douglas. Okay, so if we make McDonnell Douglas X, what does that make Boeing? 100 more than that. So like if McDonnell Douglas were 200, Boeing would be 300. If McDonnell Douglas were 75, Boeing would be 175. We can plug in some numbers quick just to make sure that our logic is there. Okay, so once we get that done, now we can just go through and solve this. So we've got 2x plus 100 equals 696. Subtract that over. Divide by 2. Now, a story problem is worthless to us if we don't know what that actually means. What does this mean? X equals 298. It means McDonnell Douglas can have 298 passengers. But what about Boeing? 298 plus 100 means it has 398 passengers. Again, this is more about learning a thought process than it is big time complicated math. As you see here, it's not real tough math, it's just, can I get it set up? Can I take the time to think about it verbally, then make it algebraic, and then solve it? And it's something we really need to be better at as we move along in this class and more math classes.